I'm delighted to introduce the winner of this year's EPS Prize, Professor Courtney Norbury. Courtney is one of the many excellent experimental psychologists that the UK has been fortunate to recruit from overseas. She did her first degree at the University of New Mexico. Then, when she came to the UK, she trained at City University as a speech and language therapist and practiced for a while in Hackney. Now, that's not an easy gig, I would imagine, before she studied for her doctorate in Oxford with Dorothy Bishop. She then went to Royal Holloway, University of London, and rose very rapidly through the ranks until she got a personal chair in 2014. And then in 2016, she moved to UCL, where she is Professor of Developmental Disorders of Language and Communication. So as that title indicates, Courtney's work has focused on children's language disorders, and she's adopted an exceptionally wide range of methods to elucidate their problems, people with language disorders. But also a characteristic is that the questions she asks always have both clinical relevance and theoretical significance. She was one of the first people to emphasize the commonalities between autism and children with, I've just learned this afternoon that it's not specific language disorder anymore, and I'm trying to make the transition. Okay, developmental language disorder. Finding that the cognitive deficits, which had often been taken to be diagnostic of autism, were shared by children with language disorders. So consequences quite possibly of poor language comprehension. And more recently, she successfully run an epidemiological study to establish the prevalence, time course, and correlates of language disorder in young school children, and only 2 studies of that kind had been previously performed worldwide. This was the first in the UK. So with great pleasure, I ask you to join me in welcoming Courtney to give the 25th EPS Prize Lecture.
Thank you so much. It's a huge honor to be here. When I got the award letter, it said that the prize lecture recognizes outstanding young researchers in experimental psychology. And I wasn't sure what I was more excited about. The thought that somebody still recognized me as young, or the fact that I was being recognized for experimental psychology, because as Celia said, that is not what I trained to do. I trained to be a speech and language pathologist. And the reason why I trained clinically is because I feel, then as I do now, that language is pretty central to everything that we do. So if you just take a moment to reflect on the language you've used today, being at EPS, you've been chatting to all your friends that you haven't seen in a while. You probably spoke to your family and your loved ones, or not, as the case may be. We use language a lot for our leisure activities, so watching films and reading books. Importantly, for the children that I see, we use language for learning. It is the foundation for learning from other people, explaining things to people, and increasingly finding out new information using a variety of different means. We use language to communicate remotely using text messages, which I didn't do when I started in this field. And because language is always changing, sometimes we get things wrong. It's very good about this. And we use language to convey our thoughts and feelings about things, be they positive or negative. This is what every morning in our household is like at the moment. So language is really central to all we do. And therefore, it's not surprising that for children who don't learn their native language in the way we would expect them to, that they are at very high risk for a whole number of undesirable life outcomes. And so as a clinician, what you're always hoping that you can do is to improve their language skills so that you can improve their life outcomes. And when I was young and a clinician, I was very naive in thinking that the best way to do that would just be to understand the language system better. And what I've come to learn through my journey through psychology is that actually it's equally important to understand the cognitive mechanisms that underpin language learning. And so that's what I'm going to talk about this evening. So how did I get here? Well, I answered an ad in a national newspaper to work with Dorothy Bishop as a graduate research assistant. And for reasons I'm still not really sure why she did choose me to do this amazing job. And so really it's Dorothy's fault that I'm here, but my fault if I get anything wrong. And Dorothy Bishop has taught me a multitude of amazing things, including how to punt and how to blog and how to tweet. But I'm going to really focus today on a couple of things that she taught me, and from that other things have grown. So really what she tried to do, I think, is help me to think more like a psychologist, and that's been very beneficial. So when I was employed as a graduate research assistant, I worked on a twin study. And so one of the things she taught me about was about genetic influences on developmental language disorders. And then my second big project was Study C, that's how I remember it forever, and this was really about pragmatics and cross-disorder comparisons, and where we really got interested in the overlaps between autism and developmental language disorders. From those initial seeds, some new branches have grown. So when you're comparing disorders, you're often comparing the endpoint of a very complex language processing system. And so in my postdoctoral work, we tried to look more at that process rather than just product. And since I've been doing this population study, I've had a real opportunity to look at development. And one of the interesting things that this has thrown up is that, in development, kids change, things are changing all the time. And yet, disorders are really stubbornly stable. So how can you reconcile these two sometimes competing forces in developmental psychology? And this brings me to something which doesn't sound like the most exciting point to end on, but it's the one that I think we really need to get right. And that is measurement is key. And something, certainly when I was training as a clinician, we all just kind of rolled our eyes when we had to talk about psychometrics. But it's really important to understanding what's changing and whether the change is meaningful. So I'm going to highlight some of those. Okay, so genetics. I'm not a geneticist. So my take-home message is it's really complicated. But certainly when I was a clinician in Hackney, this was some 20 years ago, Hackney was not the trendy, cool place it is today. It was pretty scary, actually, in places. And you certainly got a feeling there that there was a huge association between social and economic disadvantage and the fact that lots of kids were coming through our clinics with very, very impoverished language. We know from studies like Hart and Risley that there is an association between socioeconomic disadvantage, the amount of language that children hear and the input, and then their language development and outcome. But what does that association mean? A couple of people have said it this afternoon. What people assume is that it is a causal relationship. So the fact that parents aren't talking to their children as much is what is causing the children to have impoverished language. And this is a view that persists today. So what is on this slide is a report that was published in September of last year by the Early Intervention Foundation. This is a screenshot of the table of contents. There's a whole section devoted to child language and social disadvantage, and one of the key policy recommendations is around social disadvantage. This is a photo that comes from a talk by one of the authors of this report, and it really perpetuates this idea that poor language is the result of growing up on a council estate, from a single mother, in a forward-facing pram, while she's on the telephone. The only thing missing is the dummy in the child's mouth, and then you'd have the complete causal picture for what is wrong with child language. Bearing in mind this was published in September of last year, nowhere in the report does it mention a biological basis to child language disorder, nor does it mention anything that we know about genetic influences on language disorder. And I think this is not good. And one of the reasons it's not good is that when I try to engage the public and raise awareness of language disorder, these are the kind of comments that get posted in the national media. So another excuse for not bothering to work for a living. It's not genetic, it's not clinical, it's just lazy or absent parents. You can imagine if you're a parent of a child that has a language disorder, this is a really horrible thing to read in the national press. And I'm sorry that this idea perpetuates, because Dorothy's work has shown for at least the last 20 years that there are indeed genetic influences on language. And one of my first jobs was to drive the length and breadth of Great Britain testing twins. So some of those twins were monozygotic twins. Unfortunately, they weren't all as creepy as this pair of twins. And some of them were dizygotic twins, like my lovely nieces here. And we tested them on a range of different language traits. And the fairly consistent finding is that monozygotic twins are more similar in their language characteristics than dizygotic twins are. And that's important because twins obviously share environments, and the assumption is that they would therefore share to some degree the language input that they're receiving. And so this is really clear evidence that there are genetic influences. Now, this doesn't mean that language is immutable to change, as Stuart said earlier. And it still means that parents might be useful agents of change, but I think it's worth thinking about what this genetic effect means for the types of intervention we might do. And as Danielle suggested, just giving people books, if they don't have great language, if they're not good readers, if the idea that you would spend lots of time just chatting is one that makes you feel very uncomfortable, isn't going to be a great intervention strategy. It's pretty much all I want to say about genetics, except that one of the things that we found also was that if you were just looking at the genetics of disorder, it tended to be a quite messy picture because our diagnostic categories aren't always consistent, and they include a very heterogeneous group of children. So what Dorothy found was that if you looked at the genetic influences on particular language traits, you tended to get a better answer. And the interesting thing is that research is starting to show that the genetic influences on language traits seem to be common across a number of developmental conditions. So in these senses, it doesn't help necessarily to think about our diagnostic boundaries, but to think about the traits across a range of different developmental conditions. And this feeds into the next point, which is that cross-disorder comparisons are important, but they're complicated too. So this is part of study C. And the idea here was to really try and get a handle on children who had pragmatic language impairments. So these are children who have difficulties using language for social purposes, and they seem to fall between two diagnostic groups. So children who have developmental language disorders on the one hand, children with autism spectrum disorder on the other hand. So in order to look at this more carefully, what Dorothy proposed was that we would recruit a sample of children who had communication problems and administer to all of these children standard diagnostic instruments for autism. And this included parent report of their developmental history and the ADOS, which is a direct observation of their social communication behavior. And what we did at the time was just to divide children up according to their symptom profiles. So you had children who were unaffected, had mild autistic symptoms, and met full criteria for autism, either historically or when we assessed them at the time. And basically what you can see is a very messy picture, right? So if you particularly took their developmental history into account, some children with language disorders met full criteria for autism. Some had more mild symptoms of autism. At the same time, we had many kids who had these pragmatic language difficulties but didn't demonstrate the restricted interests and repetitive behaviors that would be common in autism. And we had children with autism who had language impairments. So although we were trying to categorize them in a meaningful way, what the results reinforced really was just how blurred these diagnostic boundaries can be. So what I tried to do with my PhD was to pick up this idea of cross-disorder comparisons and really try to nail what pragmatic language impairment was. This is a happy day, happy memory, Dorothy. And so to define pragmatic language impairment, what I set out to do was to find children who had problems with the pragmatics or social communication, but who did not have intellectual impairments, structural language impairments, or evidence of restricted interest and repetitive behaviors. And that was an epic failure, okay? It just didn't happen, and I worked really, really hard. Talked about recruitment. I recruited 95 children for my PhD studies who were in special schools for children who had communication disorders. We had initial exclusion on nonverbal IQ. Then we had children who we could unambiguously categorize as having language disorder or autism. That left us with a pool of children who had pragmatic and social communication issues. But again, when you looked at their developmental history, they clearly had elevated symptoms of restricted interest and repetitive behaviors, or they had clear evidence of previous language problems that required intervention from speech and language therapists. So if you're quick at adding up or subtracting, you'll know that left us with 4 children who had pure pragmatic language impairments, and 4 children was definitely not enough to do a whole PhD thesis on. So really, we didn't get any traction on that question of PLI. It did cause a lot of head scratching, though. So why couldn't we find these children in special schools? Well, one possibility is that it just doesn't exist as a diagnostic category. Clearly, pragmatic problems do, but maybe it's not a discrete diagnostic entity. The other possibility was that maybe if you had only pragmatic deficits, but everything else was developing as expected, the impact of that wouldn't be enough to get you into a special education provision. We're all in academia. We know people who have rubbish social communication skills. They do just fine, right? So maybe if you had a more representative population sample, you would see that profile, but not in these special schools. What I decided, and the way that I moved forward, was to see these pragmatic deficits really as symptoms that might arise for a variety of different reasons, and symptoms that might therefore be seen across a range of different developmental conditions. So I finished my PhD in 2004. You can imagine my bemusement some 10 years later when DSM-5 is published, and one of the things they introduce is social communication disorder. Clearly, they didn't read my thesis, because their inclusion and exclusion criteria are exactly the ones that I tried to find in my PhD and couldn't find. So I've written quite a bit about why I think this diagnostic category isn't going to work, but we'll see. We're looking at that now with Shango in our population study. Okay, one of the things that did come out of my PhD, though, was that there were some children with autism who had really exceptionally good language skills, had really good vocabularies, they were very articulate, they scored within the normal range on all the standardized tests we gave them. And these were really puzzling to me because they met these criteria. So they had definite problems with social interaction and social engagement, and they also had a restricted repertoire of interest behaviors and very ritualistic or routinized behaviors. And really together, these two things should derail language learning. Okay, so I was really intrigued by how some children with autism managed to develop such excellent verbal skills in the face of these social and behavioral challenges. And this was really illustrated very nicely by Helen Tager-Flussberg and her colleagues in Boston, who were showing this huge variation. So what we have here is scores on a range of standardized tests of language, and the red bars are the age-expected range. And you can see that here are some children who, on an omnibus test of language, are scoring at 100, so the population mean. And if they scored within the normal range on this test, they tended to score within the normal range on all the other language tests that they were given. At the other extreme, you had these children who were scoring below the 3rd centile on an omnibus test of language. And those children had this really uneven profile of language, where articulation skills were relatively spared or not impaired, vocabulary and non-word repetition were low, and then these tests are sort of made up of a lot of grammatical subtests, so they were the most severely impaired. And what Helen and her colleagues observed was that this is very much the profile of language that you would see in children who had developmental language disorders. And she posed the very provocative idea that perhaps this language impairment represents a comorbid disorder rather than just a secondary consequence of having autism. Now, really, I think you need some genetically informed designs to get at the answer to this question. But what I tried to do was to say, well, maybe the variation that we see in language is important for understanding the variation that we see in pragmatic competence. So I adopted this participant design where we categorize children according to their autism symptoms on the one hand and their language behavior on the other hand. So you would end up with a group of children who had autism but language scores within the normal range. And then you would have children who had autism and additional language disorder, which was similar in severity to the language disorder you saw in DLD. Now, if I were doing it today, I would use a much more continuous approach, but I think this was very useful at the time for highlighting similarities and differences across the spectrum. And what we did with this participant design to begin with was to really look at how variation in language affects children's ability to use context to resolve some ambiguities in language, like idioms and homonyms. And one reason to really focus on this was that there were some prevailing theories of autism at the time that would suggest that this sort of language would be difficult for everyone across the spectrum, either because they didn't understand a speaker's intention to convey something in a non-literal way, or because they had problems with coherence and therefore couldn't integrate information within a context. So what we would do is present these ambiguous phrases in contexts that were either neutral or in contexts that biased a particular interpretation. And what we looked to see was how that biasing context would change an interpretation. And what we found across a number of studies using a number of different types of ambiguity was that if a child had autism and their language scores were within the normal range, they did not differ from their typically developing peers at all on these measures. However, if they had an additional language disorder, they didn't benefit from context as much, and they looked much more similar to the children who had developmental language disorders. And this basic finding that language is important for using context has been replicated by a number of different labs around the world, so that's very pleasing. And it also tells us something important about variation within the within the autism spectrum. But people who reviewed this work, and indeed we, looked at this and said, well, you could get a similar outcome, but for very different reasons, okay? So just because they look the same on this test doesn't mean they arrived at that solution in the same way. And indeed, when you looked at some of the errors that children made, they weren't always easily explained by a lack of understanding of the language context. So for example, one child had to define what carries a torch means, and he said, it means she wears glow-in-the-dark clothes, which isn't an absence of knowledge about the context, but it's just unusual in the context that this child received. Another example comes from my clinical work. We used to do these adventure holidays for children who had communication disorders. That was a real challenge. And one of them was in the Pennines. On the hottest day of the year, we were going to go trekking across the Pennines. So we said to all the young people, be sure you wear a hat, meaning a hat that will keep the sun off your face and keep you cool. And one of the young men rocked up in his woolly hat that he'd brought for caving. Because the woolly hat came with gloves, he had the gloves on as well and wore them all the way across the Pennines, sweating buckets on the hottest day of the year. Now, he clearly knew what a hat meant, okay? That wasn't the problem. The problem was his interpretation did not fit with the wider environmental context at all. So what we started to get interested in was, well, how are they processing both the linguistic information and the wider social information? And so when I came to do my postdoctoral work with Kate Nation, she introduced the idea of eye tracking as a way of getting at people's processing of different kinds of contexts. And the first study we did in collaboration with John Brock, who was also a postdoc in the lab at the time, was to try and do an eye tracking version of the ambiguity task that we'd been doing. So in these experiments, we had 4 items, and they were paired phonological competitors. So you had hamster and hammer, and medicine and medal. And children would either hear neutral sentences like Joe saw the hammer or the hamster, or ones that biased a particular interpretation. And initially what we were looking to do was to see whether children could use the semantic information in the verb to predict what was coming next in the sentence. So we were looking initially at anticipatory gaze. But John had this really great idea, which was, why don't we also have a condition where the hamster isn't present, so the target's not there? Can children use that information to inhibit looks at a competitor when it wouldn't be important to do so? So what you would do is look at how long children spent looking at this hammer when they heard something like Joe stroked the hamster. And this is the graph that is showing our 4 groups here. And what we found was that, again, performance really linked with language, and autism had nothing to do with it at all. So here you have the typical kids and the children with autism who had normal range language scores, and they don't look at the hammer any more than they look at anything else. The children with language disorders, though, spent a lot more time looking at that hammer, having heard this sentence, even though it's contextually inappropriate to do so. And you can see the lines completely overlap, so there's no difference at all between the children with developmental language disorder and the children with autism. And this is just showing you that looking behavior correlated with the language composite scores. And so what this did was implicate inhibition as a potential contributor to poor language processing. So that was looking at linguistic context. The next thing we tried to do was to look at how children are using social context. And we were, at the time, trying to replicate a very, very famous study by Ami Klin and his colleagues in the States, who had used the film Who's Afraid of Virginia Woolf, and reported that adolescents with autism spent less time looking at the eyes and more time looking at the mouth. And they had proposed that this looking at the mouth behavior was a compensation strategy for their poor social skills. So we were just interested in what the children with language impairment would do, because we hypothesized that for them, looking at the mouth might not be so helpful. And basically, I've just got here 2 stills from that study. So this is the looking behavior of an adolescent who had autism and language impairment. We used more socially appropriate stimuli, we thought. Who's Afraid of Virginia Woolf? Quite a terrifying film for adolescents. And what you can see here is that this adolescent with autism is showing pretty typical gaze strategy, where you're looking at the eye regions of the 2 protagonists in the scene, but you're also referencing the activity that they're sharing. This is an adolescent who had normal range language skills, and this was a child who did not preferentially look at the eye region of the face, looks more at the body, and you didn't get that nice triangular gaze pattern. What was interesting about this study was that it clearly demonstrated that some kids with autism show very typical social gaze patterns, but many didn't prioritize the social aspects of the scene. And in fact, lots of children spent more time looking at things in the background. And an incidental finding was that that was correlated with their restricted interest and repetitive behavior scores. It's almost like they had a different goal. I want to know where all the light switches are in this scene, and that's what they were attending to. So this suggested potential differences for at least some children in how they allocate their attention to social scenes. So this made me think about what the impact of those differences in attention and inhibition would be on the sorts of language that children with autism use. And this was interesting to me because we've done many studies on narrative, where you would get children to tell stories from wordless picture books like this one. This is Frog, Where Are You? Very, very famous book, huge amounts of data from people all over the world on telling this particular story. And I would say about 99% of the world's population starts their story by talking about something in this area: the boy, the dog, or the frog. And one of the little boys that I assessed with autism started his story with, "There is a moon." And I had to look twice because I'd never noticed the moon, even though I'd given this test about 100 times. And the thing about this utterance is it would be marked as a pragmatic violation, because nobody ever says it. It's not how you're expecting them to start the story. And the interesting question is, why would you start the story this way? And basically what our eye tracking studies were doing was giving us some ideas of why you would do this. So if you have different goals in looking at social scenes, you're sampling the world in a different way, and therefore what you know about the world is probably quite different. And I also think that if you're looking at the world in a different way, it becomes much harder to know and to learn what is relevant to talk about. Okay, we all know that this is the most relevant bit of the scene, but if that's not what your priority is, then how do you learn that that is what other people will want to be talking about? If you've got problems with inhibition, you might just say whatever you see without thinking through what this whole scene is about and planning what you're going to say. And this could give rise to what looks like pragmatic errors. And the other potentially interesting thing about this is that if you have differences in attention and inhibition, it's very possible that children with autism will be looking at things that don't match with the language that their caregivers are trying to give them. And so the next study was really interested in how these mismatches might affect language learning. So this is a study I did again with Kate Nation and with Helen Griffiths, who was the graduate research assistant employed at the time. And what we did was an eye tracking study where we looked at how children were using social cues to learning new words. So we had novel objects, and they heard sentences like, "Show me the cello." There were 3 objects, and they had to just select the object that was the cello. And sometimes these were in a neutral condition where the person in the scene was just looking straight ahead. And sometimes that person's gaze biased a particular interpretation. And this is quite a small study. They were 6-year-old children with autism, and they are really hard to eye track. I can tell you, this is a tough study to do. But the interesting thing about them was that they had really good vocabulary. So they were matched perfectly to the typically developing kids on their raw receptive language scores and on their standard scores, which were in the normal range. But if you got them to do a definitions task, they were a whole standard deviation below the mean. So when we did this, when we started the trials, we were just measuring here their clicks on the objects. And they always saw a neutral object first, and so both groups are at chance. When they get this cue, they immediately use it. They use it to select the item that the person's looking at. And after they've seen a social cue for about 3 times, they've learned the words. And you can see that the lines totally overlap. There was no difference at all between these very verbally able young children with autism and the typically developing kids. This is the eye tracking data, which is showing you on this side how they looked at the face in the neutral condition. And you can see the children with autism showed tiny little difference in less looking at the face initially. But because the face isn't telling you anything helpful here, both groups just don't look at the face for very long after that initial gaze. When it's the bias condition, what you see is that typical kids will spend a lot longer looking at the face, and they do it in the region where they're trying to make a decision. So we interpreted this as social referencing. They're looking at the face, they're looking at the objects, they look back at the face. The children with autism spend longer looking at the face in this condition than they do when it's not meaningful, but there's a big difference between the 2 groups here. So they can follow the cue, but it seems that they don't use that cue in quite the same way that their typical peers do. And the other really interesting thing about this study was what they learned about the words that we were teaching them. We didn't prepare them in any way for this, but what we did after this task was to say to them, can you tell me anything about a cello? So we were interested if they learned the shape or the color or whether they related it to anything that they did know. And then in this one, we showed them the pictures and we said, can you tell me what this is? And what we found, we did that immediately, and then we came back 3 weeks later to see what they remembered about what we taught them. And here are the typical kids, and you can see that there's a slight improvement over time in what they remember about what a cello is and how they name it. And you can see that the typical kids are more likely to remember stuff about what it is rather than what it's called. The children with autism, on the other hand, were really, really good at remembering the names of things, much better than typical peers, but this diminished slightly over time. So what it looked like was the slight differences in how they use the social cues and slight differences in the time course of learning. This, of course, looks like a consolidation effect for typical children that wasn't there in autism. Now, I presented those findings at an EPS meeting in York many years ago. And by my very good luck, Gareth Gaskell was in the audience, and we started talking about how we could look at these possible differences in consolidation in a more elegant way. We wrote a fantastic grant together that was cruelly, cruelly rejected. And as the way things go, you know, we both got involved in other things, and it got put on the back burner, and we didn't really think about it again until the very wonderful and delightful Lisa Henderson came on the scene. And she got in touch with me, and she said, I'd kind of like to revive that grant if we can. So we applied to the EPS for a summer student bursary, and we employed Anna Powell to come and collect some data for us. And she used the paradigm that Lisa and Gareth and Anna Whale, who's here as well, have been developing with typical children and children with dyslexia, where they were teaching these novel phonological forms and then looking to see what the effect of an overnight sleep had on integration. And the idea here is that if you teach someone a new word like dolpheg and test them immediately on words that they already know that might be competitors, immediately after learning, there's no effect on what they already know because this word is not integrated with these other words. Whereas if you wait until a period of consolidation may have happened, then this word does become integrated, and as a result, decisions about known words become slower because this new integrated word is competing for activation. So, what do children with autism do? Well, we taught these children 16 new words. Again, they were between sort of 8 and 12 and had reasonably good vocabularies, but not as good as the other groups that we'd learned. This is looking at this lexical competition effect, and intriguingly, children with autism are showing lexical competition immediately, which is not what we expected and not what they should be doing. And we speculated that this could be something to do with that facility or preference for focusing on phonological information. So when you test them, they very often be intrigued with how you derived the non-word and would try and figure out what real word it is you'd messed up to get that novel word, something that typical kids don't tend to do. So you saw this effect immediately, and that diminished overnight. So they weren't showing lexical competition the next day. In contrast, the typical kids showed no lexical competition effect immediately, but huge effect on the second day, which is consistent with all the work that Gareth and Lisa have been doing on consolidation. So whatever's going on, what the kids with autism are doing is quite different to what typical kids are doing. Of course, we couldn't say anything about sleep. We didn't measure their sleep. And it was just a next day trial, so we don't know what their sleep was like or how that was related to this result. So I'm very, very happy that Lisa and Gareth finally did get that grant and that the team in New York are really looking at that now. So I can't wait to find out what happens. Next week, Lisa says. I'll call you. Okay, so at this point I thought we'd take stock on what I've done so far. So what I had learned to this point was that language variation within autism is important. And my thinking about this is that at least some children with autism will have some shared genetic risk factors that children with developmental language disorders also have. And cross-disorder comparisons to date, for me, have been very useful at pointing out the things that children with autism do well and that might support their language learning. And some of the things that some children do well is they can follow social gaze cues, and they seem to have a lot of interest in phonological detail. And that combination of behaviors might explain why they can do really well on a receptive vocabulary task. But if they're doing that in the absence of really detailed social and semantic understanding, that might be why they're a whole standard deviation below the mean on a task that invites you to give more detailed semantic information. And what this series of studies was starting to point to is some of those essential underlying ingredients that support language learning. So inhibition, attention, consolidation. And one thing that we thought was that these seem to cluster with language disorders. The other thing that we found was that those groups with language disorders very often had lower nonverbal IQ scores than the other two groups. And our favorite dispute with reviewers was what that meant. What is the important thing there? Is it the nonverbal IQ that's causing the differences in performance, or is it the language? And one thing we started to think was that, well, maybe one of the reasons that we have this cluster of things together is because we're recruiting very severely impaired children who are in alternative education provision. And maybe if you look in a population sample, you wouldn't get such a tight coupling of all these different comorbid challenges. Now, I should also say at this point, probably sounds like this is a very well thought out, well planned and orderly research career. It wasn't like that at all. And sometimes what you do depends a lot on what gets funded. So the next study, I have to tell you, we tried 3 times to get the funding for it. And I'm very, very pleased that we persisted, because Scales has been the first opportunity that I've had to really look at the development and developmental language disorder. And it does change track slightly because it's not so focused on autism, but the questions are sort of similar, and that what we're interested in is, what does comorbidity look like in a population sample? How do patterns of comorbidity change over time? And what is the functional impact of that comorbidity, both on children's well-being and performance at school, but also on how language changes and grows? So we've been very fortunate to have huge help from Surrey County Council in helping us to do this study. And what we did was we tried to recruit as many children who started a state-maintained school in Surrey in 2011 as we possibly could. We bought teachers out of teaching for a day and asked them to complete screening questionnaires for all the children in their class that included a short form of Dorothy's Children's Communication Checklist. It included the Strengths and Difficulties questionnaire, and it included the Early Years Foundation Stage Profile, which is a universally applied measure of academic attainment in children's first year at school. In the end, we had screening data on 7,267 children. I think about 40 more than Bruce Tomlin, which was very exciting to me at the time. But I do love Bruce, don't tell him Isaac. And this was our primary screening measure. I think one of the interesting things here is something that I think came up this afternoon, but what you can see is this really continuous tail upon which we force an arbitrary cutoff. We chose, for various reasons, 14th centile. So this is 14% of the population who had the most severe ratings of language and communication. The other thing I always flag is that 1% of the population were rated as having no phrase speech at the end of their first year of school, right? That is a shocker, I think, terrible. And there are mainstream classes at this point in time. The other thing you might notice here is that as you're out in this tail, many more boys are rated as having less competent language than girls. So just hold that thought in mind as we go through this. So from this sample of 7,000, we'd had a stratified random sample of 600 children. 529 of them were monolingual children, and we did very detailed assessment of their language and their cognitive behaviors and their social emotional behavior profiles. And we followed 499 of those children up to year 3. So the first thing we wanted to do is say, well, how many of these children we've seen have a language disorder? We used the same diagnostic profile that Bruce Tomlin had used in his population study in the States, and it involved 6 tests of language that yielded these 5 language composites. So we had quite a broad measure of language ability. We used a more severe cutoff than Bruce did, so we selected children who scored in the bottom 7th centile on 2 of those 5 composites, but we had more lenient nonverbal IQ criteria. And from these tests, what we identified as prevalence estimate of about 7.5% of children who had a developmental language disorder and no other known condition at the time. And we broke this down by IQ bands. One of the things we were interested in is how lower nonverbal IQ affected clinical presentation. And certainly at this age, which is 5 to 6 years old, it didn't make any difference here. So these children were not more severely impaired in their language, their behavior, or their academic progress. Interestingly, given that teachers were rating boys as being less competent, when we assessed them, there weren't any gender differences in terms of the number of children meeting our criteria for language disorder. And in fact, if you looked at who got referred, it was the girls. So some really interesting things about what we expect boys and girls to do in terms of their talking and how we treat those who aren't developing as anticipated. And because we have a population sample, we kept everyone in. So this is a group of children who have a language disorder, but also have another known clinical condition like autism or Down syndrome or cerebral palsy. Because we have a population sample, we've got a lot of kids with various diagnoses. We did find an association between language disorder and SES in this group, but not in this group. And one thing that I try to emphasize always is the functional impact of these psychometric tests that we used. So this group has increased rates of social, emotional, and behavior problems, about twice what you see in kids who don't have language difficulties. But this group, really phenomenal rates there. About half of this group have clinically significant behavior problems. And overall, children who had language disorders, about 10% of them achieved their early curriculum targets. So already at 4 or 5, first year of school, they're failing to meet their early achievement targets. And you can imagine what that does to their self-esteem and their behavior. The really interesting question, perhaps, is what happens to them over time? What are they like in year 3? So in this graph, what I'm plotting is their Z-scores in year 1 against their Z-scores in year 3. And what you can see is a pretty near perfect correlation between the two. In fact, our interclass correlation coefficient is 0.95. And when you think test-retest reliability for most of our tests is about 0.97, this is pretty phenomenal. Phenomenal stability. These lines refer to the cutoffs for 1.5 standard deviations below the mean, what most people would consider disorder. So these are the children who are meeting criteria for language disorder at both time points. These children look slightly better in year 3 than they did in year 1, but you have another group who are looking slightly worse. We think that this is largely to do with measurement error. The numbers are what you would expect given this. And it fits with other studies from around the world showing that actual change in diagnostic status is very rare at best. Language is incredibly stable. When we started to look at the growth, the slopes of growth over time, which I'm going to show you in a minute, Gillian Baird, who's one of our collaborators and who is a consultant pediatrician, said, that looks just like height and weight charts. And that really started me thinking about language and how it fits with other developmental traits. So if we think about growth for a moment, growth is where you see individual change or development on a particular characteristic over time. And if we use height as a metaphor, what this would mean is if you measured your little 4-year-old child and you measured them every year until they were 11, they would get taller. In the same way that if you measure their vocabulary increases over time. Nevertheless, height is stable. So if you took all the 4-year-olds in a reception class and you lined them up according to height, you would have some relatively short children and some relatively tall children. And if you measured that same class again when they were 11, everyone would be taller, but the relative order of children within that distribution would be essentially unchanged. So the short child is probably still the shortest child in the class, and the tall one is still probably the tallest one. And our data suggests, and data from other people suggests, that language behaves pretty much the same way. Ask any teacher. The bright, chatty children are remaining the bright, chatty children, and the ones who are struggling are likely to still be struggling over time. So we know it intuitively, but there's also a lot of evidence that this is the case from the amazingly prolific Mark Bornstein. Haven't had a chance to work with him, but I would love to. He's done some amazing studies using multiple measures, multiple ages, multiple language domains, multiple informants, showing that in general population, language is stable. In populations of children at increased biological, so premature children, or social risk, so children taking part in Head Start programs in the UK, in the USA, Language is stable, and in fact, the stability estimates are the same in those different groups as they are in the general population. And language is stable in children with contrasting language skills. And this stability maintains even when you take account of maternal education, maternal language input, the child's home environment, the child's nonverbal cognitive abilities, and the child's social behavior. So, at this point, lots of people get very depressed, but you shouldn't, because language is changing. So despite all this stability, language is changing. So this is showing you the rate of growth from our study over the 3-year period. This is the median age in year 1. This is the median age in year 3. These are the typical kids, and you can see this nice upward trajectory. We only had 2 time points, so we can only show linear change. These are the kids who have language disorders and no other known conditions. And these are the kids who have language disorders and many other developmental challenges. And the really interesting thing here is that this slope is the same as this slope. So those kids who have multiple developmental challenges, at least at this age and on the measures that we gave them, are changing at the same rate as these children at the top. So that's very encouraging. I think that says a lot about our great education system, right? Universal education is a good thing. But the fact that they're growing at the same rate means that closing that gap is really difficult to do. And these children are finishing year 3 at the point these kids were starting off in year 1. So there's about a 2-year gap that is maintained. And many studies show that at least for this group, that 2-year gap will be maintained all the way to the age of 20. So if we go back to our height metaphor again, I think there's lots of things that are similar between the two. So height, like language, is distributed in the population. Depending on what measure of language you do, it's normally distributed. And on that distribution, we apply these arbitrary cutoffs. So I liked this one for height. So here's average height, kind of tall, tall, and extremely tall. But those are arbitrary cutoffs, like the ones we use for language disorder. Height and language are highly heritable, and they're highly stable. But both, I think, are subject to environmental influences, and you can affect change. So we might not think of height as something you can change at all. Here's a really cool study that came out a couple of years ago showing changes in height over the last 100 years. And basically across the world, people are getting taller. And they're getting taller because we have better nutrition, we have better sanitation, we have better medical facilities. Nevertheless, you have some relatively tall people in the Netherlands. Marguerite can attest to that. And you have relatively small people. I don't know if anybody's here from Guatemala, but we could test that empirically later. I hope that it won't take us 100 years to change children's language abilities, but this is just to make the point that even if all of these things are true, you still can affect change. But what does all of that mean for how you might go about it? So very often, if you ask clinicians or psychologists what they want to do, what we want to do is normalize a language trajectory. We want children to grow and change at a greater than expected rate so that you can close a gap. But in order to do that, these children at the bottom, who we know have biological risks and very often are in environments that have social risks as well, have to somehow grow at a faster rate than these children at the top who have every advantage going for them. And what I've started to question is that possible? Why do we think that's possible? What would you have to do in order to get that to happen? I know for a fact the current provision that we offer is not sufficient to do it. And one question that's really come up a lot is whether there's a critical period in which to do it. So I think Stuart alluded to this earlier, and it's definitely the case for language, that if you measure language before kids get to school, the stability estimates are much, much lower. There's much more instability in the system. And some people have argued that this reflects a kind of golden period of neuroplasticity, where if what you want to do is change a trajectory, you might have more opportunity to do it. But our measures for language at this age are less reliable, and therefore it's difficult to know whether that instability reflects something meaningful about the child or whether it just is an artifact of measurement error. That's also important at the other end of the scale. So we've just got funding from the ESRC to see these children again in year 6 and year 8. My prediction is that this group will start to plateau earlier than these other 2 groups. The reason for that is that, well, there might be many reasons for that. It might represent a biological limit to their learning capacity. But I think possibly more importantly is the change in their language environments. So by year 3, about 85% of children in this group were in an alternative education provision. Almost none of them are readers, so they're not reading. And the majority of them have significant problems with peers. So the nature of the language that they hear or have exposure to is now fundamentally different to the nature of the language input that these children receive. And the other thing that is important moving into adolescence is that the nature of language that you need to know in order to navigate the social world successfully changes quite dramatically. So it becomes more abstract, more syntactically complex, more from text, and more removed from the here and now. So it might be that the nature of the language to learn just exceeds their capacity. So that's my prediction. But this is where measurement becomes very important, okay? So stability is a real pain in the backside if you want to look at developmental causal relationships. So say we kind of start with this simple model where we want to know whether variation in nonverbal cognition at the age of 4 or variation in executive function early on is related to later language ability. And if you did a model like this, they certainly would be, right? They are predictive. However, once you put that autoregressor in there, because this relationship is so strong, these things fall out of the model. There's just not that much variance left to explain. And the best predictor of later language, in our experience, is always earlier language. Of course, the statistical models are getting ever more complicated. This is fantastic work by the lovely Debbie Gooch. This was what she produced when we had what I thought was a fairly simple question, which was, does the relationship between speed of processing and language vary according to comorbid ADHD symptoms? Okay, so she produced this amazing model. And what you can see here is our very strong estimate of language ability from year 1 to year 3. But if you come down to this thing that we're really interested in here, ADHD, the estimate is about half of that. And why is that? Okay, so one of the reasons we've got such huge stability is because we've got 6 very robust tests of language that have good reliability and good validity, and we did exactly the same measures in year 1 that we did in year 3. These are teacher rating scales, okay, so they're not as robust as our language tests perhaps, and of course the teachers change, so it's different teachers at different time points, and also the reference group, the environment's changing as well. So is this lack of stability meaningful? And is that what allows you to see this relationship, but not this relationship? And if we are comparing things or including things in our models that don't have the same reliability, then it kind of messes up our interpretation. So we've had, this is speed of processing, but we've had real problems trying to model serial reaction time, procedural learning tasks, which another group of scholars has shown have very poor reliability. So often when we're using experimental tasks, they don't have that same reliability. And if you think these tests are problematic, education measures are a whole different story. They are a complete nightmare. And so it's very hard to show how variation in these skills affects children's later academic outcomes. Okay, so you've listened to me for a long time. I'm just going to summarize now the kind of key points that I raised at the beginning. So I think genetically informed research designs are important for understanding not just causes of language disorder, but how disorders relate to one another, and they might give us some ideas about how you might tailor your intervention to different families with the goal of improving the lives of affected children. I truly believe that you can't understand a particular neurodevelopmental disorder unless you understand how it fits in with a typical developmental trajectory and how it relates to other developmental conditions. So the many, many people in the world who are autism researchers And I really would encourage them to think more broadly about how autism fits with other neurodevelopmental conditions. I think understanding how and why children do the things they do is possibly more important than understanding the outcome or the what they do. And we have heard and often think about how our research can inform theory and practice. But coming from a clinical background, I think it's important for us all to remember that practice is really important for informing our theories and the way that we ask questions about those theories through our research programs. So I think Maggie Snowling and Charles Hume have a version of this. They call it the virtuous circle. And I think it's important to remember that it goes both ways, that our clinical insights can really be important in developing our research and theory. Language is incredibly stable. I think language itself is malleable, but I do wonder whether rate of language learning is malleable, and that has important consequences for how we think about intervention. Certainly the issue that we brought up earlier, there is no quick fix, right? We have to allow the system to cope with the fact that some children are going to have ongoing language learning needs. And doing all of this has shown me how many challenges there are for understanding development. Okay, longitudinal studies, as we all know, are quite challenging. When you throw in developmental disorders, they become even more so. So we've had some comments today about a common currency. People use different terms for the same thing all the time. They use different diagnostic criteria. They use different assessments to reach that diagnosis. And that makes comparisons across research groups very difficult indeed. We've also talked about sample sizes and how difficult it can be to recruit children with developmental disorders. If you want to look at development over time, the duration of our grant funding is wholly inadequate, usually around 3 years, and so you spend half of the time you're supposed to be doing the longitudinal study trying to get the money to follow them up over time. And what all of this has taught me is that there is huge need for collaboration, and especially cross-disciplinary collaboration. So if scales is a wonderful thing, it's not because of me, but it's because I've had a fantastic multidisciplinary team that involves clinical psychologists, statisticians, psychiatrists, and pediatricians, as well as experimental psychologists. And close working with education staff and speech and language therapists who are at the coalface. That's why it's a great study. And of course, what this cross-disciplinary collaboration would help us to do is to think more about what we're measuring and how we measure it so that we can identify meaningful change over time. I'm a big fan of the bottom line, and the bottom line for me is that understanding language development and disorder requires a lot more than understanding just language. And for that, I'm really grateful to Dorothy and to my time in psychology for helping me think about that in a more useful way. So I have a lot of other thank yous. One to our funders and to Surrey, who have been utterly amazing. So these two wonderful women got the study going, and they have now left Surrey, but there's another group who are really helping us to liaise with schools and to keep things going. And we have 180 schools taking part. So teachers and SENCOs have been really helpful to us. And of course, we work with many, many children and their families who really enrich our research program. I want to thank the lab and our friends. Most of them are here today. The Scales team, so it's a big team. These are our collaborators. So Debbie was the postdoc on the first round, and Sarah is the postdoc on the new round, and they pretty much make things run in an orderly fashion. These are the rest of the team. These are the people who go out and collect all the data, so we're very grateful to them. I wouldn't be here without some fantastic champions, and I've been very lucky to work with these people. And finally, and thank you for listening.
Courtney, thank you. Yes, in time. Thank you very much for that really illuminating and improbably uplifting lecture. You really have a gift for bringing results to life with examples, but also for looking on the bright side of language development and of science. It was truly uplifting. Now, there won't be any questions. Now we're going to have the poster session and a drinks reception, and I'm sure that Courtney would be more than happy to talk to anybody who would like to approach her at the reception. So let's just say a final thank you for a great lecture.
Thank you.